Welcome back to Mr. Slover's Math. Today we're going to be focusing on solving multi-step equations. So recently we've focused on solving one-step equations, and now we're getting into two-step and three-step equations. All right, so this is just a warm-up, just to remind you of some things we did the past few days with inequalities, or what like terms are, which like terms have the same variable, which is your letter, X, Y, Z, or whatever letter you choose, and power. An example of like terms is 7 and -10. They are like terms, they're both constants. So when we solve two-step or more, like a multi-step equation, your goal is still to isolate the variable. You want to solve for that variable. And to do that, you're going to undo the order of operations. So this means you're going to add or subtract before you multiply or divide. Now, as we know, math has some weird languages and weird rules. So we need to keep that in mind, that sometimes you're not going to add or subtract first. Sometimes you could multiply or divide first. But for all the problems that I'm going to give you, you're going to add or subtract first. But I want you to realize that that's not always the case. I'm just designing the notes for you to have just addition or subtraction first. So example 1 says solve the following equations. Work is required. This red line I refer to as the fence. It's just a way to stay organized. It's a way to collect like terms when we get into multi-step equations, especially when there's like terms. So further down the road, that'll come into more play. But right now, it's just kind of there. It's just an organizational thing. So my goal is to get the 4x all by itself. Well, it says 4x plus 3 equals 27. Okay, the 3 and the 27 are on different sides of the equal sign. That's what this red line is indicating. They're on different sides. So I cannot combine them to get 30. So once again, I cannot do that. They're on different sides of the equal sign. So 4x plus 3 equals 27. This is addition, so I need to do subtraction. That's the inverse operation of addition, subtraction. So I'm subtracting 3 from both sides of the equal sign. Okay? And this line is reminding me that what I do to one side, I have to do to the other side. That's your laws of mathematics. Right? It balances your equation. So I'm subtracting 3. Now 3 minus 3 becomes 0. That's why I crossed it off. There's no need for me to put a 0 in there, because if I add 0 to anything, it does not change the problem. So I didn't do anything with that 4x, so I brought it straight down. I'm doing 27 minus 3 on the right side, which gives me 24. So now I'm at 4x equals 24. Well, we're back to what we did yesterday with one-step equations, or one-step inequalities. To undo multiplication, you have to divide. So this is saying 4 times x, we want to divide by 4 to undo that multiplication. 4 divided by 4, I'm left with x on the left-hand side. Now, yes, it could be 1x, but realize that 1 times x is still x. So if you want to, you could put the 1 there. I choose not to. That's just a personal choice. On the right-hand side, we're going to do 24 divided by 4, and that gives us 6. So our solution is x equals 6. So if you were to take x is 6 and substitute it back in, you would get a true equation, or a true statement. Now, we're not requiring you to check your work, but if you want to, you can. You're more than welcome to. Okay, let's check out a different example. Let's go to letter A. Directions are the same. Negative 3x minus 8 equals 25. I put that fence in there, so I know the negative 8 and the 25 are on different sides of that line, that fence. I cannot combine them. So since this is subtraction, I want to add 8 to both sides of that equal sign. Negative 8 plus 8 becomes 0, so that's why it's crossed off. I still have that negative 3x. Make sure you bring that negative with it. Negative 3x, and then on the right hand side of the equal sign I have 25 plus 8 gave me 33. So now I've got negative 3x, or negative 3 times x, equals 33. So I'm going to divide both sides by negative 3, and I get x equals negative 11. Let's check out letter C. So letter C, I've got a division in here. It says m over 3 plus 4 equals 16. Well, this m over 3, that's my term I want to get by itself. Just like up here in letter A, I wanted to get the negative 3x term by itself. I want to get this variable term by itself. Okay, so first, I'm going to get rid of this positive 4. So I'm adding 4. I want to subtract 4 from both sides of that equal sign. So 4 minus 4 becomes 0. I'm left with the m over 3. This is negative 16 minus 4. And if you're not good with negatives, use your calculator. Plug it in just like that. Negative 16 minus 4. You get negative 20. So I'm left with m over 3, or m divided by 3, equals negative 20. Well, to undo division, I need to multiply. So I'm going to multiply both sides by 3. Negative 20 times 3 is negative 60. And the last one I want to talk about is letter E. So negative x plus 7 equals negative 19. Your goal, once again, is to get the x term or the variable term all by itself. It means I need to subtract 7. I'm currently adding 7. This is addition. To undo addition, I need to subtract. So I'm going to subtract 7 from both sides. 7 minus 7 becomes 0. Negative x drops straight down. Now this is negative 19 minus 7. So that becomes negative 26. And if you notice here in red, I rewrote this. This negative x is really saying negative 1 times x. So in order to undo that multiplication, I need to divide. It is very common for students to want to add 1. And it makes sense. It's a negative. You want to add it to get rid of it. But this is negative 1 times x. To undo multiplication, you have to divide. So we divide both sides by negative 1 in this case. So negative 26 divided by negative 1 is 26.